everyone, we're looking at lesson 5-3 today, using points to find a linear equation. Let's do some review problems before we begin the lesson. We want to solve for the slope given 2 points here. Question number 2, what is the missing variable in these 2 points here given that the slope is -1? So let's look at problem number 1 and problem number 2. Do both of those and then we'll come back to the answers for them. Okay, so hopefully you got problem number 1 correct. Answer is -6, so you are simply taking your slope formula as we've done before, y2 minus y1, which is -7 minus 5, and x2 minus x1, which is 2 minus 0. And you're subtracting that, so I just changed this minus sign to a plus. It's a little silly to do that down here, but I just kept it consistent. And you'll get -7 plus -5 is -12 over 2 plus -0 is obviously just 2. And -12 over 2 is -6. So there you have it. Slope here is -6. Just a quick review there. Number 2 is a little different. Here you're given the slope. So we have the slope here, which is given to us. And on this one, what we're doing, so that's given to us. That's the slope right there. And what we're given here is a point, but this other point is incomplete. So we don't have the y2, okay, so that's missing. So we think about, well, let's kind of go backwards here. If you're given the slope, which you are here, so I just rewrote the slope. That's the slope that's given here to you, right? And kind of go backwards and say, well, let's think about what. So this is y2, right? That's missing, and then this is y1. So y2 minus y1, well, we don't know what y2 is, right? So we would just write question mark -3 over, and then this is our x1, right? And x2 is my -1 here, subtracted by x1, which is 4. And I changed the minus into a plus, and so you see that this is -1 plus -4, which gives you -5. So we're kind of going backwards here and saying, well, answer is -1, right? So my denominator is -5. So think about what the numerator should be. What should the numerator be if the denominator is -5 and the answer has to be 1 or -1? So my numerator here should be 5, right? 5 divided by -5 is -1. Okay, so what number, if you think about it, -3 is 5? What number -3 is 5? And that number is 8, right? 8 minus 3 is 5, and 5 divided by -5 is -1. So the variable is, in fact, 8 that's missing. Sometimes questions like this might pop up in some tests that you'll be taking in the future, and it's good to be able to, manage them. Knowing your formula, your slope formula and such is very helpful, and being able to understand, okay, well, if I'm missing a y here, that must be something that will give me the final answer, which is given to me. That is the slope. And so I will kind of work backwards to figure that out. Okay, so let's go to question number 3. Write the equation now in slope-intercept form. Given that the slope is 1/2 and b, which is the y-intercept, is -5. I want you to solve that yourself and then go ahead and write the equation in slope-intercept form of given 2 points, 0, 3, and 2, 7. Just to get you started, to remind you I'm sure you do remember, slope-intercept form is y is equal to mx plus b. And we want you to be able to write both of these, number 3 and 4, in slope-intercept form. We'll come back to it. Okay, so we're looking at question number 3. So the slope is given to us, which is 1/2, and the y-intercept is -5, and we simply just substitute right here the slope in for m and the y-intercept in for b. And we did that right here with 1/2, substituting that in for the slope, which is m, multiply that by x. Remember, the slope is always multiplied by x, which is your input or independent variable, and the y-intercept is the constant at the end, which is b. Now, we also talked about how if you ever have a y-intercept that's negative, you don't want to have those double signs. So just go ahead and change the plus negative to minus. So your final answer should be y is equal to 1/2 x minus 5. This is just all a review, so you'll remember all this. Let's look at number 4 here. Write the equation. So we're given 0, 3, and 2, 7. If you recall, when you're looking at, and I just kind of sketched this graph, just a freehand sketch of 0, 3 is right here, and 2, 7 somewhere around here. We just draw a quick line there and just visualize where this line is going to start. It's going to start at 3, right? 0, 3. And that's 3 on the y-axis, which is our y-intercept. And so that's why we're going to have our y-intercept is going to be 3. And remember that if you ever have 2 points and one of the points has a 0 in for the x-axis, when x is 0, the y is b, because we know that the y-intercept is where the line crosses the y-axis. Okay, so from these 2 points, I can also solve for my slope, which is very important for you to remember for today's lesson. We're going to just take just the same thing as we did on problem number 1, just 7 minus 3 and 2 minus 0. Subtract, divide, and we get slope is 2. Now, with the slope being 2 and the y-intercept being 3, which is these 2 points here, let's substitute that back into the formula, which is y is equal to mx plus b. I can rewrite that right here underneath here for you. Y is equal to mx plus b. Remember, your slope is always being multiplied by x, and the y-intercept is at the end. So just line it up, substitute the slope and the y-intercept where it needs to be, and your final answer is y is equal to 2x plus 3. Okay, so we're going to go ahead with that review and start our new lesson, where we're given 2 points and we want to find the equation, linear equation given 2 points. So we know a couple of things here. When we have a linear equation, when we need a linear equation, we know that our formula is y is equal to mx plus b. And from the previous questions that we saw and we reviewed, we know that we need a slope and we need a y-intercept. So those are the 2 main important items that we need. So we need the slope and we need the y-intercept, and then we just substitute the x and the y, and there you have it. We'll have our equation. In this case, we can comfortably, hopefully, I know these numbers are a little big, but that's okay, solve for the slope. So I want you guys to go ahead and copy this question down, solve for the slope, and we'll be right back with the rest. Okay, so hopefully you guys got -5 for your slope. Just simply doing what we do with subtracting the y's and the x's and putting the change in y in the denominator and the change in x in the numerator, and you should have gotten -5. So at this point, it's great that we have the slope. What about the y-intercept? Well, if you recall the previous example here in example number 4, we knew what the y-intercept was because when x is 0, remember the y would be your b, which would be your y-intercept. But in this case, these 2 points, none of these 2 points has a 0 for x. The first point is 5, and the second point is 7. The x values, I mean. Okay, so what we're going to do is we're going to do a little kind of trick to figure out how to solve for b. And you got to pay close attention to this because this could be a little confusing. So what you're going to do is you're going to pick one of these 2 points. Okay, so you're going to pick a point. You could pick 5, negative 19, or you could pick 7, negative 29. So you're going to pick one point, and that would be your first step. Okay, and when you pick that point, it doesn't matter which point you pick, just pick one. And we're going to pick here 5, negative 19. It does not matter which one you pick. You just pick one. That's your first step. Okay? And after you pick that, you're going to label the point x and y. You don't need to put x1, y1. You just label it x and y. And what you're going to do is substitute this x and y into the equation. So the next step would be to substitute x and y into y is equal to mx plus b. And what that will do is it will allow you to solve for b, because right now we have the slope, we just don't know what b is. And to solve for b, we can do this by substituting one of these points into the equation and substitute our slope into the equation. And this is what happens. So watch what I'm doing here. So instead of the y here, okay, I'm substituting negative 19 right here. So I'm putting in negative 19 instead of y, okay? Instead of the slope here, remember this is m times x, right? So when multiplying mx, we have the slope here that we solved for, right? We're going to substitute the slope in right there for m. So that's negative 5. And instead of x, what am I going to substitute for x? You got it, this 5 right here. So I'm going to take the point, I meant to do that with red, and I'm going to substitute the x, the y, and the m in for the y, m, and x. I'm going to substitute negative 19, negative 5, and 5 in instead of the variables. And what I have left here is going to be, my only variable left is going to be b, which is what I want to find. So I'm going to go ahead and solve this. This kind of looks like a trail, doesn't it? So I'm going to rewrite this here. Negative 19 is equal to negative 5, which is my slope, times 5, which is my x, right? Oops. Times 5, which is my x. Plus b. The b is what I need to solve for. And as you can see, when you have an equation, to solve for a variable, all the other equations, all the other variables need to have a number instead of it. And we do. That's the whole purpose of this. We have substituted a number in for the y, the slope, and the x in order to solve for b. So we're going to go ahead and solve for b. So this is going to be negative 19 is equal to 5 times negative 5 is negative 25 plus b. And these are, we haven't done this in a while, but one-step equations that what you're going to do is simply balance your equation. So you've got b on one side, negative 25 here, and negative 19 here. What we're going to do is we're going to add 25 to negative 25, and that cancels this out, and balance your equation. So you're going to add 25 on the other side. Whatever you do on one side of the equation, you must do the other. So negative 19 plus 25 is going to give you 6. And there you have it. B now is solved, and b is equal to 6. So now we were able to solve for b. Okay? Now I have my slope that I already solved for before, and I solve for the b by substituting the x, one of the points, as for the x and y in my equation, and I solve for b. So now I can go back and answer the question. And the question is, what's the equation? Our equation, remember, is always going to have just a number for the slope and the y-intercept. Our final equation should not have any numbers for y and x. So we're going to go ahead and just write our equation with the slope that we solved for originally, which was what, negative 5, right? And our y-intercept b that we got, which is 6. And we're just going to go y is equal to, my slope is negative 5, x plus 6. And there it is. That's your final answer. Y is equal to negative 5x plus 6. I don't like the way I wrote that. Let me rewrite it here for you. Meter. Once again, y is equal to negative 5x plus 6. There you go. And that's the final answer right there. So we did do some fancy things, right? We did do some fancy things. The final answer is negative y is equal to negative 5x plus 6. Let's kind of review what we did right now. And what we did was we solved for the slope just using the same technique. Got negative 5 for the slope. Then we picked one point. It doesn't matter. If you had picked 7, negative 29, you would have gotten the same answer. And in fact, I encourage you to do that to see if that's the case. It should be. And so 5, negative 19 is what we picked. And we substituted 5 and negative 19 for the x and y. Just be careful with this, because some people tend to put the 5 where the y is supposed to be. And so make sure that you put the right variable, the right number, and the right substitute in the right variable. So negative 19, of course, is y, so it gets substituted instead of the y value here. And then the slope was negative 5, which you already had. And the x here is right there, 5, that you have right there. So just in case, you might want to, if you want to highlight these for yourself, right there, I have different color highlights that I can use. So I can use like negative 19, I'll highlight it in green here. And then, you know, you're substituting it in for y, you're substituting the 5 in for x, and then the slope is negative 5, and we're just not going to put any highlights for that to keep it simple here for you. So be careful when you're substituting. So we went ahead and we substituted the negative 5 in for the slope. And when you do all of that, you'll notice that now you've got the y-intercept all by itself, which is what you want. You want the y-intercept to be the only variable in your problem here so you can solve for it. Multiplying the numbers down here and subtracting or adding it over will balance your problem and give you the b, which is 6. This part you might be a little rusty in, so we'll work on it in class together as well. Let's go ahead and have you guys try to solve the next one. So write an equation the linear equation given 2 points right here, which is going to give, the points are 5, 7, and 25, 23. So you're going to use the same technique as we did before. Hopefully you took good notes on it. Use the same technique, solving for slope. First thing you want to do is that, and pick one of the points and substitute it into y is equal to mx plus b to solve for b. So first thing you want to do is solve for slope. That's your first step. So solve for the slope. That's your first step. Then you're going to pick a point, right? And you're going to substitute that point for x and y into the equation. And you will be able to solve for the y-intercept in that case. So y is equal to mx plus b, and you'll be able to solve for b after you've substituted all these values into the equation, okay? And once you have b, you're going to go ahead and then use the b and the slope to find your final equation, which is going to give you your answer. Except your final equation, you just want the slope and the y-intercept in it. So that would be your final answer. Okay, I'm going to give you guys some time to finish this up, see if you can handle it on your own. We'll come back to it. Okay, so we're going to go ahead and look at how to solve for the slope. Again, 23 minus 7, you subtract the y's, and 25 minus 5, subtract the x. I got 16 over 20, and I went ahead and I reduced 16 over 20, divided the top and bottom by 4 to get 4 over 5. And I'll show you why I did that in just a second here. And we can see that dividing by 4 will allow you to see that we can cross-simplify this here. So when you're looking at y is equal to mx plus b, remember we're going to substitute the x and a y from one of the points, and I chose 5 and 7. And you could see that 5 is my x, and I highlighted in green, and I substituted, instead of the x in the equation, I substituted 5. And then the 4 over 5, I substituted that in for slope. If you change that to 0.8, which is the 4 divided by 5, that would work too. We just try to encourage you to keep your fractions intact so you know how to simplify them. Well, 4 over 5 times 5, you can cross-simplify these two. You see that? So cross-simplifying these 5s, you'll get a 4 on the top. So you'll see that, so of course substituting 7 in for y as well, and we'll get 7 is equal to, now the 5's canceled out here, so 7 is equal to 4 plus b. And we could see that we're solving for b. We're going to subtract 4 from both sides. And we solve for b, which is 3. Write this down for you here. So I'm going to clean this up a little bit. It's not looking very nice. Okay, let's do this again. So 7 is equal to 4 plus b. And I'm writing the b in red so you could see. Oops. B, so you could see that we're solving for b here. Subtract, of course, 4 from one side and 4 from the other side. It's balancing your equation. We're going to come up to balancing equations next week. So 7 minus 4 is 3. Still not getting enough room here, but hopefully you'll follow me here. 3, and then of course 3 is equal to b. Okay, so b is 3. My slope is 4 over 5, right? And if we actually wanted to graph this, it would be easier to graph it, of course, given a fraction for the slope rather than a decimal. I'm going to go ahead and substitute the slope in for 4 over 5 in the equation and 3 in for b, right? And then the rest of my equation is done. Y is equal to 4 over 5x plus b. And there you have it. That's your final equation. So you're going to use this equation twice. You're going to use it once to solve for b, and the next time you'll use it is to write your equation. Of course, for your equation, all you need is the slope and the y-intercept, and which is, we figured it out. We solve for the slope and we solve for the y-intercept using this technique that I showed you. Okay? Let's go ahead and look at this problem here. I'm going to go ahead and erase this piece. I'm going over top of your problem here. Write a linear equation given the table. Now this time you're given a table. And with a table, you're going to be given a whole bunch of points. But what you should remember is, if you are looking at a linear equation, right, it does not matter which points you pick because they're linear. All the points are on the same line. So you could pick whatever point you want. You just pick 2 of these points. You know how to solve for the slope, right? And you solve for the slope, you just pick 2 points, and then you're going to go ahead and solve for the y-intercept, which is b, using the same technique as we did on the 2 previous problems here with problem number, well, the 2 previous ones we did. I don't think I numbered them. So go ahead and copy this one down, this table. Table has, for the x values, -2, 1, 6, 8, and 10. For the y values, 2, 5, 10, 12, and 14. You're going to go ahead and solve for the slope. You're going to go ahead and solve for the y-intercept. As you can see, this table does not have a 0 for any of the x values, so it won't give you a y-intercept. You're needing to solve it using the technique that we just did. I'm going to let you guys try this on your own and come back to the answer. Okay, so once again, we went ahead and I picked 2 points out of the table. I picked the top 2 points here. I just didn't want to do any negatives. So try to stay away from negatives as much as you can, if it's all possible. 1, 5, and 6, 10. Subtracting and solving for, and dividing and solving for the slope, we get 1 as the slope. Now, given we solve for the slope, which is 1, which is right here. I changed the color to blue. And I picked one of the points here. This time I didn't pick 1, 5. I'm going to pick 6, 10 here. So you can pick any point you want from the table. Because this is a linear function, it's a straight line, so any point is a part of the equation. So you could pick any of the points. But we're just going to pick 6, 10 here. Substitute 6 in, and just be careful with this step. You're substituting 6 in for x, not for y, and then substituting the 10 in for y. Substituting the slope, which is 1, into the equation. So we get 10 is equal to 1 times 6 plus b. You're trying to solve for b. In order to solve for b in this equation, every other variable has to have a number. So you can solve for b and get a number for b and know where the y-intercept is here. 1 times 6 is 6. Now subtracting 6 from both sides will balance our equation and allow us to solve for b. We're going to subtract 6 from both sides. Here we'll get 10 minus 6 is 4, and b is equal to 4, and there you have it. b is 4. Now that we know that b is 4, that's y-intercept, and the slope is 1, we can substitute both the slope and the y-intercept back into the equation, and there it is. Except we don't want to write 1x, right? So we just substitute that in and write y is equal to x plus 4. And there is your final answer right there. So we solved the equation. You use y is equal to mx plus b once to substitute the x and the y and the slope to solve for b, and then substitute the slope and the y-intercept in the equation and get your equation. There you have it. Let's get one last example here just to make sure that you guys are comfortable with all this, because this can be a little tricky. Okay, so copy down this problem, our table. Solve using the same technique. So you want to find the linear equation using the table, and we'll come back to the answer. Okay, so we picked, I picked 1, 6, and 10, 60. If you picked other numbers, that's totally fine. We should get the same answers. So for the slope, I got 6 as the slope. I did my subtracting and dividing. And then I went ahead and I picked another point. And the second step where you're supposed to pick another, you can pick whatever point you want in this table. So instead of picking 1, 6 or 10, 60, I picked 7, 42. And substituted those in for my x and y. Substituted the slope in for 6 and substituted 42 and 7 in for x and y. And I got 0 for my slope. So you guys should have gotten 0 for your slope. If you picked any other points, you should have gotten the same answer. And that's okay to get, I'm sorry, not 0 for the slope, 0 for the y-intercept. Okay, so it's okay to get 0 for the y-intercept. That's a proportional relationship. That's where the line is going to start at 0. That's totally fine. So my equation will be y is equal to 6x, right, plus 0. And of course, we're not going to write plus 0. We're just going to write y is equal to 6x. This is a proportional relationship, and it starts at the origin. Our line would start at the origin and have a slope of 0. I mean, the slope of 6, sorry. Okay, so we'll do more practice problems that are similar to this, and yeah, hold on for the practice problem.